Ready. Ready. Ready.
Hello, welcome to Enlightning. Today we're going to learn about open policy containers, and we have Gert Drapers here with us to teach us. Welcome, Gert. Tell us about yourself, please.
Hi, Whitney. Nice to meet you. It's like this first virtual date, right? I'm Gert. It's like from a little startup called Lucerdo. It's like we maintain, and I'm one of the maintainers of the Open Policy Container project. Been doing a lot of other open source related work, started in Cloud Foundry, for example, and I've been in container land or related to that since ever. And so, yeah, that's about me in a nutshell.
In Containerland, I'm relatively new to tech. I wrote my first line of code in 2019. Oh, we have a guest here from Australia. Hello, welcome. Please do say hi in the chat and say where you're tuning in from. I love that this is a global community. It's the coolest thing. Yeah. Hi from India. Koramaju's here. Hi, Koramaju. Thanks for being here, friend. So I'm relatively new to tech, and so I only know a world with Kubernetes, but I understand there was a world before. Tech still existed beforehand.
Started way before that.
Tell
There
me
was no
about
Kubernetes.
tell me about what it was like post containers, pre Kubernetes. What was that world like?
Well, we had Mesosphere,
Yeah,
right, which was
is that an orchestrator?
It was a big orchestrator. It's like it's like at that time, it's like I actually was working for Hewlett Packard. And so that was one of the projects they invested in besides OpenStack, which was like not containers, that was like big VMs. And so
okay.
Cloud Foundry was like not containers, but was a very interesting workflow, right? It's like sort of derived from Heroku.
Okay.
But it's like, yeah, the world before Kubernetes, Docker Compose, that still exists. It's like people like the elegance and the simplicity of that. Right? I use it.
Nice.
It's like not for everything. Is like Kubernetes is like the go-to part, I think. And it's like with all the hosted container solutions, I think there's also is like, of course, a substrate. Now, they themselves might be running in Kubernetes, but it's like the end user is like who uses container instances in whatever form is like the very small one. It's like the Firecrackers and the Fargates of the world. They might be very different, but yeah.
Yeah. It's been really interesting to watch the landscape change. I think when I first started in tech, everyone kept saying shift left, shift left, shift left. And I have no idea what they were talking about. I didn't understand enough about where people were. And then like just the terminology of shift left didn't make any sense to me. But it's
it's a right shift.
Yeah, and now I like, took some time, got to understand what everyone means by shift left, and now it's like, okay, let's make the developer experience easier. Like it's almost like let's give the developer more responsibility for their stuff, and then now it's like Now let's take it back, but make sure like they still get to make the right decisions, but they don't have to deal with anything more than the stuff that's important to talk to. with
Yeah,
a
I think
particular
in real
application.
life, I think the answer is in the middle.
Isn't it
It's
always?
like you can create this very well-tended garden for developers, but they will always find angles where it's like they need to have certain control. They
Yeah.
need something different. It's like this. I
Mhm.
think I think Heroku was a good example that did this reasonably well and is still around in terms of a level of abstraction that allowed developers to be productive and efficient, and also make it accessible to a broader audience. Because I also think that that is an interesting angle. Kubernetes is like if you need to start there, is like there is so many things that you have to understand and learn.
It's true.
That it's like it takes you a moment to actually get there. Now, when you're there, it's like, so we started our startup right in the pandemic. We were container first. We were Kubernetes first. We moved cloud providers, hosted environments, and it's like it only takes us a week to move from one to the other.
Wow.
And so it's like, because if you're a startup, you live on borrowed time and borrowed money, right?
Yeah.
You also is like get these nice credits from these cloud providers. So it's like you go to one, and then it's like I'm there, and then it's like you move to the next one, and so you results, which is it's useful because it's like we gained experience in all three major ones by now. But it's like it sort of demonstrates the fact that it's like it is reasonably transparent of where you want to run, which Kubernetes you run, because it's like they built some very good abstractions. Now, still, you can make decisions yourself that completely throw that out of the window and make it sort of moot, because it's like you're stuck to this because you're using this one cloud vendor or this one piece of technology that can't move.
Yeah.
So.
Yeah. Those of y'all in chat, are you all using Kubernetes? Oh, we have a Dominican Republic. Hello. Or do you know, I loved hearing even just the story of you jumping cloud providers, because it really paints a picture of startup life. I've only ever worked at like the big corporations. Taniwa's here. Hello, Taniwa. So like this scrappy, it just paints a picture of being efficient. I really like it. So I'm going to start moving behind the light board. So open policy containers, I deliberately like to know pretty much nothing about any of the technologies that I cover on the show so that I ask good questions from behind the light board. But this is what I know about open policy containers. I know that it builds on open policy agents, and I'm 90% sure it works with SigStore. Is that true?
Yep.
Okay.
And
so those
and it brings together the Open Container Initiative.
Okay. Oh, the open OCI. Okay, so I'm gonna move behind the light board. What I would like from you, Gert, right now, if you don't mind, is to give some. I've done episodes on SigStore. I've done an episode on Open Policy Agent. But for those of the people who are joining right now who might not know about those things, will you give a brief overview of those tools? And I challenge you, do not talk about open policy containers yet.
That will be
those
hard.
Don't do it, because I have to move my sounds from here to there, and I might not hear everything you say. And I want to get all the good stuff on the board.
So I have 2 minutes of freedom. That's what you said.
You can talk so much trash about me. I will have no idea. I'm going to drop a link to open policy containers in the docs here, and I'm going to head over and tell us about Open Policy Agent and SigStore, please.
All right, perfect. So for those who are not familiar with the Open Policy Agent, it's a decisioning engine that has been created by the Styrat team. And so it's a very generic decisioning engine at the end of the day. And so the policy language is very flexible. Therefore, also is like a little bit more complex, maybe to some people's opinion, but that's not the point. But it allows you to make decisions. So it's, for example, if you're a Kubernetes user and you're using So conf test, for example, is leveraging it. It's like there's admission controllers that can leverage the OPA standard just to determine, do you have access or not, which is a very generic decision, right? Is the door open or the door closed? If somebody asks me is like what business we're in and they don't know anything about authorization, because that's the line of work that we're in, is like I basically say is like I stand at a door and determine if it's open or not for you, right? That's what we're trying to do, and that's what OPA is trying to programmatically give you access to. Now you can use it in two forms. You can use it as a standalone service, or you can use it embedded. We started using it embedded as our decisioning engine to help us solve an application authorization problem, right? And some people do that on their own, right? They take OPA and start building around this to do the same thing. So what we try to do is like build an application authorization solution on top of that. That helps. That's really developer focused. That was our main angle.
Are you talking about open policy containers?
No, I'm talking about OPA.
Okay. You said we. You said we, and I was afraid.
No, it's like, well, it's like this is not just me doing things. It's like it's a concerted effort of the people. It's like the great team I have inside our little startup and the community at large around us that actually helps us build these kind of software.
I love it.
But it's like at the end of the day, it needs to be applicable to solve people's problems.
Mm-hmm.
Right,
Absolutely.
and so that's how we ultimately will get to open policy containers. Now, the Sigstore and cosign initiative is an initiative to actually provide a signature story to prove that container images are not tampered with. Right, and so again, it's like, as I said, it's like, so we're standing on this little project, right? The Open Policy Container Project stands on the shoulders of these other enormous projects inside CNCF, right? Mm-hmm. Open Policy, the policy agent is like Sigstore was their cosign initiative, and the Open Container Initiatives basically is like a format of distributing artifacts and the registries around this, and this is where it all started from.
Beautiful. That was great. I'm here. I want to say hi to some folks in chat. We have Tim here. Hi, Tim. And we have Findle. Hi, Findle. Glad you're here, friend. All right. So to help me understand, please, especially since I'm new here, I don't know how long I'm allowed to say I'm new to tech, but I'm going to write it a little longer. I love the content. That's not going to
last very long.
I would love to hear what the world was like before open policy containers existed that caused it to get created. So what were the problems? Yeah.
So it's sort of since the beginning of our journey, right? We started using the open policy agents, and the open policy agents promote something that is near and dear to my heart, which is policy as code. Right? Separate the policy definitions from the implementation, right? And don't embed that part of the code inside your application. For the reason, there are two main reasons for that. You want to be able to evolve your policy because your business rules as an organization, they will change constantly, right? Governments will change things, regulations change, your business problems, and you're growing as a company as well. So it's like you want to have something that's flexible. So making that external to your application was a key feature. So when you look at how OPA does policy as code, you write some rules, you package them up sort of as in a build process, right? It's called OPA build, and it will create a bundle. And that bundle is a tarball, right? And that tarball is then distributed to the places where it's like you run your application. So great. But we quickly figured out, it's like, how how do I reason about which version is this? How do I reason about, is this the right one? It's like, can I tell the engine to automatically update? Because we came out of the container world. So we're used to Semverse, right, tags, and it's like all these nice things that the Docker workflow gave us.
So can you back up so I can stay caught up with you on the board? So open policy agents distributes policy, and the policy itself is a tarball?
The policies are combined and grouped together.
Right?
Okay. So there are multiple policy files. You can have data files. You can have WASM files. You can have a manifest file. All these things are built. If you say OPA built, it creates a tarball called bundle.tar.gc, right? Literally, that's what it is. And so that's how it's like that works. No problems with it. But it's like the challenge that we saw was, as I said, it's like, I have policy as code, so I want to do CI. And I want to have my policy in a GitHub repo. I want to build it. I want to build it once. I want to distribute it. And then it's like, I want to consume it. Right? How do I tell OPA that I want to run version 1, 2, 3 and not latest? Or how can I tag it to version 1? And it's like I'm leveraging Semverse, right? Semantic versioning. If there's a new version that's being released, that it automatically will pick it up. So that's how this all got started. So the first thing was, we need a workflow to actually help developers build this.
So the problem's no versioning, no tagging, just like no metadata related things, right?
There's no metadata, right? And it's like there was also the distribution mechanism for those tarballs was put them on an S3 bucket. Or on a file share, or it's like there are all sorts of ways, because it's just a file, so it's like you can do whatever you want. But that it doesn't give enough rails to a developer to intuitively do the right thing. So now, if you imagine the Docker workflow, which is Docker build, tag, push, pull. Right? What does that do? Well, it creates the artifact, produces a generic, or not generic, but a common artifact, which follows the specification, the OCI specifications, that allows us to embed metadata that have multi-layers that can be signed by a Friends of CoStore, right? Or the SIG store, the cosign initiative, is like it can be distributed to a registry. Therefore, it's like I can unlock all these primitives to create a workflow for policy as code that is 100% parallel to how developers write their code today. Right? It's now no longer this foreign entity that says, it's like, I need to create a tarball and I need to copy it around and I need to look at the SHA. It's like, yeah, that's what OCI does for you under the covers at the end of the day. But it's like, that's how this whole thing got started. Right? And so it was, how do we create the workflow? That workflow needs to allow me to version. We do that through tagging. We want to include metadata. We want to be able to identify that it's like we have integrity. So it's like a secure software supply chain. Because if this is a policy that guards who has access and who has not, I would like to know if the policy that I'm deploying is what I think I'm deploying. Right? So that's why we started investing in the cosign work to make sure that it's like we can sign that policy. And now it's like we can verify that when we actually receive that on the other end.
This is making a lot of sense. One thing when I was just open policy containers, it uses OPA. I couldn't understand why a policy would need to be in a container just because policy itself seems like configuration. Really, it's not like a piece of code that runs and needs like a base OS and all that jazz. So
It's
yeah.
so, but that's, I think, the evolution of containers as well, right? So what you're describing, right, a base OS, it's like, or a root OS that I have in my container. That's the world from OCI v1, right? And it's like OCI.
I just very quickly we have a comment, OSI, you say. We've been talking a lot about the different levels. So OSI, Findle, is Open Systems Interconnection, and that has to do with networking. And we're talking about OCI, which is Open Container Initiative, which is a standardization around how to create containers and move them around, store containers. Yeah.
So OCI, the Open Container Initiative, right, has a whole set of specifications. One, the most important one for the Docker and Kubernetes community is like, what is the physical layout, right, of how these containers are laid out on disk, right? So it describes the streams that you have inside your container, the metadata of what is described, what's in there, how can I walk up to a container, interrogate it, etc. There is the registry specification that says it's like, this is how you interact with this central place where you can store them and retrieve them, right? And so these two are the most important elements of the Open Container Initiative. And so with V2, there is a push to use the OCI specification as a more generic artifact distribution mechanism. Right? What you see in the WASM world today, right, is that one way of distributing WASM components is done through an OCI container. And an OCI container doesn't have to contain an operating system.
Yeah.
We use it to distribute plugins, for example. Why? Because I like the distribution mechanism that I can go to a registry, interrogate the registry, see if there's a newer version, pull it down. It has a very well-defined download strategy and all these things that come with it. So that's how I think it's going to be helpful. The other part is like, by taking this approach, right, as I said earlier, it's like one of the objectives is, can we, for policies as code, can we deliver a secure software supply chain?
Yeah.
So can you trust those artifacts that you're distributing?
Yeah.
Right. So
we have some questions in the chat. If now's a good time for those. Does this apply to decentralized technology like blockchain, or is it a centralized implementation?
It has no opinion about if it's centralized or decentralized. It builds on top of these building blocks. Now, it's like, in terms of blockchain has certain connotations for me. I think that those are not directly related, or maybe not even at all. I'm not sure how to answer that, to be honest. But it's what embracing the OCI's standards, right? The Open Container Initiative standards allows you to to create artifacts in a well-defined form, version and distribute them, right? And you're distributing them through this registry, and then it's like the party who consumes it pulls it from this registry, can ask the registry, are there newer versions? So that's what it tries to, or has enabled for us, right? It's like Kubernetes lives and breathes on that metaphor, right? In terms of a pod, right, pulls down an image from the registry. It knows what kind of image that is because it's described by the metadata, and it has certain assumptions about this. And so what we're trying to do here is leveraging that great work that the OCI initiative has started, right? And combine that with the other projects.
Mm-hmm.
Right? I see this project as sort of a glue project.
Yeah.
Right? It's like we saw this problem about how do we create a developer workflow that they understand, that is common to them. If they have been exposed to Docker, which most developers these days, they have been this close to the Docker workflow in some form. They have seen Docker builds, Docker push, Docker pull. Right? At least Docker pull. Maybe they don't build their own containers, but they're consuming them. Right? Every developer who has to run something on their local machine these days will go do Docker pull Postgres. Right?
Yeah, I want to highlight some chat comments. Thindle's raising their hands. Like, I've done that. Docker files are magic. Thindle's a developer. Thindle's here from the developer side and not the cloud side. Taniwa has some experience. At a previous place, we would store signed OPA policy in an S3 bucket and point all the OPAs to go download it. It was simple, but it needed a bit of work to make sure that S3 bucket was organized properly and only updated through appropriate processes. It's also,
it's like, can I tag on to that one, because it's like, that's exactly right? It's like, that's what the world looks like. And so in this particular case, Tanawi is like, has created, it recognized the problem and solved it, right? As a one-off. Right? And it's like, so yes, if you recognize the problem and sees like, all right, we need a central place. We need to ensure who can put it there. We need to have a versioning scheme and probably encoded in the folder structure of your S3 buckets, right? It's like or in the naming convention of the files. Right? All those things are taken care of by the OCI artifact by definition.
Yeah.
Right? And that's the beauty of it, right? It's like, it sort of commoditizes the solution, right? I'm not stating here that it's like anything is novel, right? We're just bringing these things together to come up with a solution to the problem of versioning and distribution and integrity that builds on top of these known quantities and by blatantly reusing them in the same fashion to solve the problem. Right?
Absolutely. So then Taniwa says this also means you can use things like TOF for policy distribution. Why is the project open policy containers? Is there a container that's part of it?
There is an image it's like, yes, it creates containers.
Okay.
Right? The container in the OCI v2 definition, right? We create policy or container images. What we stick in there are the policy artifacts. So the Rego files, the data.json files, the manifest files, and we package that in a container. We have the right metadata around it. You can, and again, then it's like you can optionally say, it's like, I'm going to sign this, etc. Then it's like you're using the OCI registry infrastructure to distribute it. And then it's like we contributed to the open policy agents, the initial implementation of the OCI downloader. So you can now start your OPA service pointing to an OCI registry.
Cool.
Now, what that allows you to do,
I think we're getting a little bit ahead of ourselves. If you don't mind me slowing you down, I want to get a good definition of like open policy containers on the board. And then I think I want to like unpack a little bit of what you've already said. And then we can go on to the open container initiative downloader that's part of the OPA project. If that's
the
cool.
open policy container definition would be, it's like all the artifacts required for an open policy agent to function, or it's like it can function on a tarball on the bundle as we described, but it's like so it contains all the artifacts that you need, right? Stored in a standard mechanism. That's definition number one, right? So standardize the persistence format. right? Because that's what OCI is giving us. So all the OPA artifacts stored in a standard mechanism, right, called the OCI specification, V2 specification to be specific. All right, that gives us the ability to now use semantic versioning, use labeling, use metadata, right, to learn about these policies that are inside the container. And so you just created this wrapper around it, around the OPA artifacts, that allows me to reason over it in terms of what is it, when was it built, where was it built, who's building it. It's like, that allows me to get to this situation where it's like, and this is, at least from my perspective, the ideal outcome of a container world. You build once and you use it many times. Right? So you build, you make it available in a central or a distributed location, one or multiple registries, and people can start to use that artifact. Right? And now it's like you can leverage that to actually, it's like reduce the work, right? It's like, that's, if I have my Postgres container, right, I would, it's like I build it once, and then it's like there are millions of people using it, right? And they all trust that artifact that is like, that is a Postgres container of that version, and it's all that things. So that's ultimately, I think, what we're trying to achieve here, is enable that workflow of creation and distribution.
In a standardized, in a industry, I wanted, so here's what I have so far. Open policy containers are a collection of OPA policy related artifacts stored in a standard way, which is OCI v2, that allows the user to add metadata, to version, and to distribute OPA policy. I kind of want to say in a standardized way, but really I want to say, like, I want to say something about how ubiquitous OCI and like accessible, how accessible it is.
Right.
You know,
it's like, so, because it doesn't make, right, by putting it inside an OCI artifact, there is no difference from a registry, therefore distribution point of view, between a Alpine container that has code in it and your application and your policy. Right? It makes it ubiquitous.
Yeah.
Right? And it's like, it also means you can leverage the same infrastructure. If you have Artifactory or a Docker registry or GHCR or ACR or ECR, it doesn't matter, right? They're all OCI container registries.
Oh my God.
And if they support, and most of them do these days, this v2 specification, right? You can put a lot more artifacts in there than just container with a base OS. Or a root OS, sorry. And so that makes it that it's like these registries become a pivotal or a very important element in any developer environment. Right? And people want to be able to reason over, is like, what are the artifacts that I have? I can go to these things and also do gather intelligence from it's like in my previous life, is like we would scan our registries for vulnerabilities, for known dependencies. That's like if you look at what Sneak is doing, right? Sneak is like is very good in scanning all these dependencies. It's like there's like ones that is like focus on doing this, turning the container inside out and figuring out if there's vulnerabilities in there because of the layering system inside these containers. Right? It also is like, right now it's like we took the first step, right, to get this going and to get it wired into OPA. we still conform to the bundle format that originates out of OPA.
Okay.
If you reason over that, it's like ultimately where you want to get to is you want to start leveraging the dependent layers inside a container.
Okay.
Right? If you start to think about it, it's like I'm going to have an OPA instance that leverages WASM, right? Or it's like it has a lot of data files and a lot of it's like a manifest file and these various Rego files. You want these compartmentalized because some of these artifacts don't change at the same time. And what I mean with that is like, so for example, in an OPA world, it's very common to have some reference data that you want to look up in your data.json files or JSON files in general. Why do I have to recertify and re-sign my code, my Rego code, if I don't have to? Now, if it would be in a separate layer and that layer would be signed, I can update my reference data, which is much more common to update more frequently. Right? And those are capabilities that is like this unlocks once we start really going with this.
I'd love to dig in. First, I want to say hi to Napalm Codes. Hi, Napalm Codes. So glad you're here. I want to talk about, I think maybe it would be worthwhile to say what's in a bundle. First of all, I want to validate this. I've come up with a definition as you were talking. Open policy containers are a collection of OPA policy-related artifacts stored in a standard way that allows
inside an OCI image. Yes, OCI v2 stored as an OCI v2 image. Right?
Okay,
and that's by being an OCI image, right, a container image. You gain all these properties that you listed after that, right? An OCI image has an ability to describe metadata, right? The OCI image has a naming convention that says it's like this is the registry, this is the name, the image name, and this is the tag, right? And so that allows you to get the versioning aspect nailed down. It's the OCI ecosystem, right, broader than the OCI specification for the image, defines the distribution mechanism characteristics by defining what the registries are, right? So what this simply does is embrace that ecosystem, right? The OCI ecosystem to enable all these characteristics on top of the OC or the OPA policy as code workflow. Yeah.
So do you think it would be useful to talk about the collection of artifacts that's in a open policy container, and then maybe we'll say something about how those are stored in different layers?
So just for clarity, right? Is like, so we could talk. So there are three main artifacts, right? That is like an OPA policy contains.
Okay.
There's a manifest file, right? It describes what is in here. Says something about versions. Can contain signatures. There's some other artifacts in there. There is.
So this is a policy, not a policy container.
Right. This is what. Okay. So a policy. Effectively, you have to go back to what is the policy bundle contain, right? Okay. The policy bundle contains a manifest file, one or more Rego files, right, in a directory structure that make up a namespace. So it's like that's actually important to preserve, right? Because if you start flipping files around, it's like that might not be giving you the desired effect. So there is sort of implicit information derived from directory structures there as well. And then there's like, we have the data.json files, which are the data that is like you can load into the OPA engine to help these rules make decisions.
Okay.
Right? That's the standard way of working inside the OPA engine.
Okay.
So Today, as I said, it's like we're still banking on the fact that it's like what's inside the OCI container for now is the same tarball that we create with OPA build. Why? Because that was the most expedient way to start adopting this, but also to prove that the OCI, the container workflow, is actually the thing that is like we want to unlock. Right? That you can start to use a registry, etc. And so right now, the current state of the universe, if we look at OPA 0.60, starting from OPA version 0.39, I think is when we first introduced the OCI downloader. And they're about to go GA. So that will be a huge event for the OPA community. That's a great milestone if we're going to pass that. All right. It's like that's the state of the universe today. Right? That's what we're doing. Now there has been and that dates back 2 years ago. Two folks in the community created a proposal of how we could actually do multi-layering in an OPA world.
Okay.
Now, they started from the let's make it an OCI image and layer it. That didn't gain any traction at the time. There was interest in it, but it's like it never got to an implementation. And so we took the approach is like, all right, let's ensure that it's like we can use the workflow first. And so we turned that problem around and said, it's like, all right, we're going to take the existing artifact and layer that into an OCI image so we can start banking on the top of the workflow.
Yeah, makes sense.
Because our customers wanted to use a CI environment. So we have created a bunch of GitHub actions that allow you to check in your rego code, your data.json files, your manifest, and it's like it will run CI, it will run tests, it will run linting. It's like it will go build the artifact, push it up to a registry, and now I can start to use that container, right? That policy image. And so now it's like we still want to go to the world where it's like we have multiple layers because there are benefits to that. But that means it's like that's the engine who is consuming this would need to start understanding this. But we made now the first, as I said, it's like that's been out there for, I don't know how long it's been. I think it's a year plus that it's like it has been integrated into the OPA engine. We have an OPA-based authorization service sitting next to that, which embeds OPA, that is also banking on this workflow to make it available. Right? So we know now that the workflow actually works, and it's helping people create a controlled policy as code workflow.
I think that maybe that workflow would be a good thing to capture on the board. The workflow, the open policy containers enables.
Yeah, it's if you would, it's 100% analogous to the Docker workflow. So you start with policy build.
Does open policy containers have a short way to write it? Like an abbreviation? OPCR? That's gonna save me. OPCR. Okay.
Because that's also is like OPCR.io is the web or the domain name that is like will get you to the initiative. That's the shorthand version that is like we coined when we started this. And so the CLI that comes with this is simply called policy. Right? It's a very non-descriptive name in that regards, but it's policy built. Right?
Okay.
It's exactly the same sort of argument structure as you would do Docker build. So you point it to where your source code is, and you give it a tag that says like this is how you're going to build this.
policy your like the CLI name?
Yeah, the
Cool.
the CLI is called policy.
Nice. Okay, so policy build. Point to directory.
Yeah, where your source is, and then it's like a tag that creates a local policy image, right? And that's exactly what Docker build does, right? Docker build takes your code, looks at the Docker file in that particular case as sort of the wrapper that is like tells you them what to do, and it produces a container image in the local policy store or in the local OCI store, right? And so policy CLI does exactly that. It has a local OCI store. So you're now is like you built your artifact, you made it that we know it's syntactically correct, right? We can build it, and you can point OPA to it. You can point Topaz to it, which is our version of the authorization engine that consumes this. And then it's like you can start testing this, right? So that's the first step for a developer is like, all right, I can now have an environment that I can spin up on my machine. I don't need anything fancy beyond that. I haven't touched the registry yet, but it's like I know that it's like my code is syntactically correct, and I can start running it. So that's what policy build gives us. Now, once we are done with that, we want to start distributing it, right? So, okay, how do we do that? We give it a tag that points to a server. So let's say GitHub, ghcr.io, org.
Before,
push it.
Will you say one more thing about testing the policy locally? Will you just repeat that?
So testing the policies is like, there is no policy test as such. In the form from the policy CLI point of view, because it's like we deal with the bundle distribution problem, right?
Okay.
So, but what a developer will do is like it will say is like OPA start or run serve a service endpoint, and in the config file point to the local policy instance to load it up.
Okay.
Run OPA test.
Okay.
Run the Rego linter. Well, probably you want to run that before you build, but it's like it's an interactive process where the developer goes through, right? So they can do all these things locally. They don't have to actually get more than that. And so once they have the artifact in a state that this is like, okay, I'm good. I want to start distributing this. The next thing is to tag it. So the tagging, as I said, is like we'll have it. This is the service, the registry service where I go to. This is the organization name, but that's part of the registry definition. All right, so let's say it's ghcr.io whack Gert D. That's my org name on GitHub. Right. And then it's like I call my policy demo. Right, so if I do tag, I will say policy tag, what pointing to the local policy image, either by ID or by name, just like in Docker. And then you say GHCR, blah, 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 Gert D demo 0.:0.0.0, right? So I have now a Semver address or a Semver label created. That's still only local. Now it's like you need to distribute it, and we do that same way as in Docker push. So this is policy push. So policy build, policy tag, policy push. Right, these are the three ingredients that I get to go from source code to an artifact that I pushed into a registry.
All right. We have a comment from Tony Wong.
So I recall the properly OPA allows backend plug. I think the backend plugins if I'm not mistaken, are part of the commercial, the Styra OPA version, the Kafka plugin and these things. So I don't think that they're actually in the open source versions. Now there is a plugin mechanism, but adding a plugin to OPA is a code change. That's why it's like we run with an embedded OPA, because it's like we add plugins to our own system.
Uh-huh.
But it's like, so there is right now, I don't think it's like that can be distributed as part of the bundle. If it can, it's like we should be able to get it into the image. But I'm not aware that that's possible outside of the. I'll check it out. Learn something
Thanks,
every day.
Taniwa. Yeah, love it.
So much to keep up with in the open source community that it's like, even it's like if it's your job, it's like you.
Tell me about it. Excellent.
All right, so now it's like in these 4 steps, we created a policy and we pushed it to a registry, right?
Awesome.
Now the counterpart of that is the consumption part, right? This is the publication part, right? So creation and publication, and the consumption part is very simple at the end of the day. It's policy pull, right? Just like you pull Docker pull, you pull it from a registry image or from an image down, that brings it into your local OCI store. And now it's like the service that's using it, if that's Docker or in our case OPA, is able to use it, right? So to consume it, you either implicitly or explicitly perform a pull. I say implicitly or explicitly, it depends on how you want to think about this. Is like, so if you want to do it from the CLI, it's literally called policy pull, and it will show up in your local container store. If you would tell OPA by config, get it out of reference this artifact in this registry, it will download it when the service starts. And it will keep checking if they're updated versions. Now it's like, how does it do that? Because it's like, so if you give it a semver, it will basically get the SHA from the semver and make sure that it's like, even that if the semver is like, so say it's like you bounce to 2.0, right? The patch version is open. If there is a new patch, it will see that. So it's like OPA has a discovery or a timer mechanism by default between 60 and 120 seconds, where it will go check if that SHA has changed. If the SHA has changed, the downloader will kick in. It will bring it down into the engine, bind it, and start using the new version. That's the standard OPA mechanism for doing this.
So to consume,
that's not to us.
To consume a policy, you could use policy pull to pull it locally, or we could point OPA to the policy in the registry.
Yep. And the same is true for our open source version of the authorizer called Topaz that does the same thing. Right? Same, because we embed OPA into that project. It's like that's how we do that. Right?
Cool. I put Taniwa's URL on the screen for those of y'all who aren't in Twitch with Taniwa. What important parts of this story do you feel like we still need to capture on the board? We talked about some background of the problem. We talked about open policy containers definition and the artifacts that make up OPA policy. We talked about the workflow to create and publish and consume policy. You mentioned, as someone who's not as well versed in the scene, you mentioned something about like an OPA downloader, which I don't understand the value of that right now. What is that? I don't know whether to put it on the board. First of all,
No, it's an implementation detail of how OPA interacts with this right now, or is able to interact with it. As I said earlier, it's like, so we chose to go down the path where it's like we keep the internal artifact, the bundle definition, the same. So at the end of the day, OPA knows about the bundle. Right? That hasn't changed. Now it's like we wrap that bundle inside the OCI image to get all these properties that we discussed at length. Right?
Love it.
Right? And so the OCI downloader in OPA is the thing that knows that you pointed to an OCI location instead of a S3 bucket.
Okay.
Right? Because if it's an S3 bucket, it will simply say, it's like, oh, I expect to be pointed to a bundle, right? To a tarball.
Okay.
The OCI downloader knows that it's an OCI artifact, knows the semantics of how to interact with the registry.
Okay.
Download it based on the semantics of semantic versioning. Make the bundle available to OPA as it was a regular bundle.
Love it.
There is no magic there. It's like it's.
I forget
Too
what
many
right now.
OPA is OPA, OPCR, like OCI is like this. This is the acronym soup version of this.
One thing we haven't talked about yet is SigStore or Cosine specifically. So Cosine is a sub-project of SigStore. Maybe that would be a good place to go next. What do you think?
Yeah, because it dovetails nicely on the workflow that you have next to it, right? So OPA today has their own signing of artifacts that they had for a long time.
Okay.
Now, one of the, if you think about it from a security angle, it's like this is a constantly evolving topic, right? It's like, and so it's a specialized field. So my approach in this is like, hey, if we can leverage these specialized projects that are just the only thing they do is focusing on this problem set.
Yeah, I love that.
In a way that it's not just specific to OPA, but generic to the OCI container environment. I would prefer that, right? So what's the Cosine initiative gives us is the ability to, when we produce the artifact, so after step 4 after step 1 effectively of your policy build, right? You can say, it's like, hey, I want to sign this, right? So I use Cosine to create my key set, right? It's like I'm going to sign this particular artifact. That gives me a public key and a private key in the Cosine world, right? And then it's like, I am going to push that signed policy up into my registry. Now, the advantage that, or the thing that enables is somebody who's consuming the artifact can now use Cosine verify using the public key to say, it's like, hey, is this still the same policy? Or is this the same image? Is it been tampered with or not, right? And so when we consume it, right, we can do a pull. So it's like on the bottom part. So after step number 1, either the implicit or explicit pull, you would do a verify using the key, right, the public key, that you then can say, it's like, hey, this, you draw such a great art. I'm looking at this and I'm like, yeah, it's like, and it's like PowerPoint doesn't do that for me. It doesn't remove, if I have crossing lines, it doesn't automatically remove it. So, So, but that allows me then to leverage that to say, is like, hey, what's the integrity of my image? And the reason why I like it is, as I said, it's like it's not specific anymore to OPA.
Mm-hmm.
I can use this for every OCI image that I'm using.
Mm-hmm.
And so, one, I think that's a more reusable workflow.
Mm-hmm.
Right? It also doesn't tie you into something. And
Mm-hmm.
I, in all honesty, it's like I rather have that is like the OPA community can spend their cycles on the OPA engine, right, on the decisioning engine, and don't have to worry on
Yeah.
the encryption part or is like the signing part of an OCI of a bundle.
Well,
Right?
yeah.
Because
Not
that's a
only are
solved
you,
problem.
yeah, it's a solved problem. Let's be silly to do it again your own way.
And so
yeah.
it sort of allows us to, as a project, now like this hasn't changed yet, but it's like that's ultimately I think it allows us to say, it's like, all right, this problem has been solved for us, right? It has
Mm-hmm.
been solved by working within this ecosystem, and
Mm-hmm.
that's personally is has been my objective of this whole project. Is as I said
Mm-hmm.
earlier, is like to glue these things together, right?
Mm-hmm.
OCI has a great definition of how to store things. The registry has a great way of distributing things. Docker
Mm-hmm.
unified a workflow that is pretty ubiquitous around the industry these days. Right?
Mm-hmm.
So let's build on top of that, combine that with an initiative like Cosign that is like is giving this capability to all container images.
Mm-hmm.
Right? And so at the end of the day, we have a better together story with a great workflow. So
Absolutely.
it's like all we're doing in this little sandbox project is tying these things together in a workflow that makes it hopefully easier to consume.
Mm-hmm.
Right? It was really motivated from the anybody who has to create a bundle to create a workflow that they can understand, that is easy to set up. It's like you can tie it into source code control, you can tie it into your CI/CD pipe, and it should just behave like your regular code. And that was ultimately the objective of this whole project.
I got too excited and I wrote over where my face goes. I guess I'll just kind of squat now. I do that.
Can you find the spot in this, like in the notes where we can still see you? Yeah.
Yeah, maybe I'll rewrite this part. Cool.
So I'm interested. It's like for the people on the chat. Is like, does this all make sense? Does it like? Can you see? Would it help you? Because I think that's ultimately why we're doing this. Is like we started this because we saw a need for ourselves, for the projects that we're doing, and so we're using it there. So we know that's getting used. But it's like, and so it's my last is like in Chicago at KubeCon. It's like I was on the Contributors Pavilion, also talking about this subject, and it's like met people who was like didn't know about it. Were intrigued about it, saw the use of it, but it's like I love to get feedback on the project, and it's like in terms of, hey, is this helpful? What are we missing? Right? Is like sort of the next thing in terms of how can we make it even better?
Taniwa says that they can see it being useful. Not everyone can afford to build a team of people to maintain this kind of infra, and this makes it easier. I think, Taniwa, your description of what you used to do before with their S3 bucket, I'll bring it back up. I think that was really illuminating for me to help understand what problem is being solved.
And I think he's not alone in that. Right? It's like I think it's it's a good summary, right? It's like if so here we have our one-line summary.
Because Yeah, I can imagine that it's a lot of work to set up, that it's a lot of work to maintain, that like when someone new comes on the team to have to communicate how it all works. There's room for humans to fail. Like what, it's not
Yeah.
automated. Like I can see how a
Well,
solution like this would be great.
yeah, and again,
Um,
that was the and it's the same what we do with other code, right? It's like how do we
mhm,
make our engineering teams scale and not be repetitive, right? It's like this
mhm,
is one of the things is like when I started when we started our startup is like automate, 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 right? Everything
mhm.
is like because we can't scale. It's like we started with 2 people. It's like soon we had 3. It's like right now we're at 12, I think. But it's like
Oh, nice.
we need to focus on how do we make the best use of all these things. Also, given all the interactions that we have with projects and community interactions, etc. And
Mhm.
so it's part of staying alive. Is that we have to automate uh, our repetitive parts and make
Oh
them
yeah.
repeatable and have those workflows tell us
And
if we don't make it.
and
So,
version control too is beautiful. Mwah. So maybe that would be a good way to use this last little bit of space is to kind of summarize all the benefits of doing it this way. What do you think about that? Or is there something else you'd rather do here?
no, I think we covered all the main things, right?
Great. I think it's been great. Yeah.
And so
Um, yeah.
it's like so if you start from the frame of is like right what that we started off is like so policy as code, right?
Uh-huh.
That assumes right the as code part for a lot of people is sometimes the hardest because people in that deal with uh, decision engines or authorization systems, security systems that are OPAs deployed, they're not necessarily developers. So they're not living in GitHub and or
Yeah.
Jenkins or is like these kind of systems. So for
Mm-hmm.
them, it's like making policy as code sort of actionable. Right?
Mm-hmm.
You need to make it accessible.
Hmm, I
Right?
like that.
So
Mm-hmm.
that was sort of the first step is like when we started talking to prospects and people who wanted to use our project was like, how do I do this? I see a piece of code there, and it's like I understand what you're telling me. That is like the as code part, right? Which says,
Mm-hmm.
all right, put it in source
That's
code
great.
control, version it, build it, automate it, test it. It's like all these
Mm-hmm.
things. It's like they understand the words, but they've never practiced it.
Mm-hmm.
So how do we do this in this policy world? And so that's what we were trying to achieve, right? It's like, so the policy CLI can bootstrap your source code project. It has a little templating engine that says like policy templates apply, create me new policy, right?
Mm-hmm.
So that gives you scaffolding for your OPA project. It spits out the config file, a rego file, etc. It has a template to add it to CI in GitHub or GitLab because most of the people we spoke with, they've never
Mm-hmm.
done that, right? And so just to help them getting started, it's like, all right, here's like 3 questions you need to answer for is like which GitHub repo is like which what is the key that we need to use so we can push. That's it. And then it's like, here,
Mm-hmm.
you check it in. Now we need
Mm-hmm.
to learn them about Git tag, right? Because
Mm-hmm.
that's also new to a lot of those folks. And so
Interesting.
they have a lot to learn, right? If
Uh-huh.
they say, like, I'm going to embrace policy as code. And
Uh-huh.
before you know it, it's like they wake up screaming because it's like, this is all these things I've never done before. It's like as a security professional or somebody who's wiring in authorization into the world. All right. So
Uh,
it's because it's these roles are very hybrid, right? They're very close to the business, to the organization, regulatory things, and then it's like they're in engineering, and so that's these people have to consume a lot of different things. And so making it easier, that was like sort of the key thing, making policy as code accessible, right? By also leveraging existing metaphors. Because so if they talk to their engineering counterparts, application developers that probably are exposed to a Docker workflow, they start to have at least some commonality of things they can talk about that is like apples and apples. And it's like, oh, a build creates an artifact. Okay, then I distribute the artifact. So that's the sort of how I would summarize it, right? In terms of like, that's the ultimate objective that we were trying to achieve with this.
Is to make it more accessible, make it more usable, and then it'll be easier to implement policy. Taniwa has a lot of nice comments. I enjoy Taniwa. The approach is simple. But there's a lot of complexity in building it. Their way of doing it, and a mistake can lead to consequences. Code with Sean's here. Hi, Code with Sean. Also, no CISO, do you say it like that? Will accept this if it's too complex for them to understand. So good descriptions on what happened and where are important. Absolutely. And this is one day the CISO wakes up and realizes they built a DevSecOps org. It's so true.
Yeah, so true. Yeah.
And then hello again to Code with Sean. Thanks for being here, friend. So I guess I feel like I kind of captured the big benefits. Captured it down here. Did you want to say anything more about like integrating with GitHub Actions, or maybe how to join the community, or where to go to learn more?
So to learn more is like go to the OPCR.io website. That's the short form of it. It's like as people discovered it, we'll expand to a longer version, but it's like it has all the details of how to get started, how to get the tool. And from there, it's like, so our GitHub org is also called OPCR-IO. And OPCR-IO, dash in the middle.
But this is your regular website,
that's the website. The GitHub site is, github.com/OPCR-IO. And so that's where you will find all the code. Everything is open source. That's where you will find the GitHub actions, the GitLab tasks. It's like, if you want to contribute, I don't think there's a lot of issues that are open, but it's like there's some. But it's like, that's also how you can reach out to us. And so you can ping us. It's like, I think there are 5 maintainers right now. So
cool. Easy to use. I think we did it. I guess I'm going to start a summary of everything we've talked about, make sure we have it all squared away in our heads. And then if anyone has any questions or comments or feedback, please do weigh in right now. Now's your chance. So here we go. Long time ago in a galaxy far, far away before open policy containers, a lot of folks are using open policy agents because it has policy as code, which is great. You can decouple a policy from apps. And OPI, unrelated, but OPA policies are grouped and distributed as a tarball, which we'll talk about more later. So this has some problems, this tarball. There's no versioning, there's no tagging, there's no metadata, and the distribution mechanism is not standardized. It's just a file. Taniwa actually in the stream described how they used to use S3 buckets to distribute their open policy agent files. So these problems of the tarball specifically can be solved by packaging and distributing policy with the OPI specification and containers. OCI. So the Open Container Initiative, OCI, it was first made for container images, but now can be used for other artifacts too. But it allows you to create, version, and distribute artifacts in a well-defined form. Yes. And so open policy containers, that's where they came in. The star of the show. Open policy containers are a collection of OPA policy related artifacts, which is called a bundle. Again, we'll talk about it in a minute. It's stored as an OCI v2 container image. And this allows the user to add metadata to the bundle, to version it, to distribute OPA policy in a way that leverages industry standards. And so it leverages industry standards in that it uses OCI, but it leverages industry standards for citing too. So spoiler alert. An OPA policy contains 3 main artifacts. This is the bundle. So it has a manifest file, it has 1 or more Rego files in a directory structure that it's important to maintain it in that structure. And then it has a data.json file, 1 or many of those, and that makes up the bundle. So then OPCR, which is Open Policy Containers, uses OPI to distribute and package and add metadata and sign this bundle. So it's super easy to use as a workflow to integrate into your CI/CD systems. You actually use it just like you could integrate it with commands that are very similar to the whole Docker process. So we talked about a workflow to create and publish. To create and publish these policies. And so we could use, there's a CLI tool called Policy, and that's part of Open Policy Containers. And that's, so you would run the policy build commands, and just like Docker, you point it at a directory, you add a tag, and that will create a local policy image. And then you could use that image, you could validate and test the policy locally if you want to. And then when you're ready to push that to a registry, just like Docker, you tag the image with the registry, you use the command policy tag with the address of the registry. And then just like Docker, policy push to push the policy image to the registry. And then to consume the policy, you use policy pool, which pulls it locally, or you can point OPA to the policy in the registry and OPA can take it from there. So that's pretty cool. Then we talked about policies being signed. So a policy image can be signed during this policy build step using cosign, which is a subproject of SigStore. It's an open source project that verifies OCI artifacts. And then the policy image also with cosign when it's consumed, it can be verified during the consume steps. So that's more or less it. The big benefit is policy as code itself is a huge benefit, but to really be able to leverage that benefit, to make it actionable, it needs to be accessible where folks can get to it easily, and then also easy to use. And then you can learn more at the website opcr.io. I think that's a wrap. Do you have anything to add or say? Yeah.
No, I think you're hired. This is the best summary I've ever seen. It's like on one screen, everything together. So
amazing.
Awesome.
That's exactly what we set out to do. And Tani wants us to summarize before and after. Is that a happy? That's wonderful. We're doing the thing. All right, that's a wrap. It's a happy dance time. At the end, we dance our goodbye. So if you don't feel comfortable, you can dance maybe a little bit, just move your hands. Or if you don't want to dance, that's okay. But I'm going to dance my goodbyes and my thank yous. And here we go. Let's, there it is. Goodbye, friends. Thank you, Gert, for sharing your time and your expertise with us. Thanks for those in the chat. Thanks for asking great questions. Thanks for those who watched the recording. You're the best. I appreciate you. Goodbye.
Bye.
That was great dancing,
Right.
Gert. I saw your hand
Right.
up there for a second.
Thank you.